This video is going to go through how to figure out the oxidation numbers of these elements. Now we're going to do this in a pretty simplified manner, but essentially what we're going to do for an oxidation number, we're going to look at, when we do this, we're going to look at the, it's going to end up being a positive or negative number that indicates how many electron has gained, lost, or shared to become stable. Alright, so that's what we're looking at right up there. How many it has to gain, lose, or share to become stable. Right, you're like, well, how does it become stable? Remember, a full outer shell is what we're looking for. Alright, so we want a full outer shell, whether it be 8 or if it's early, the early initial element's 2. Alright, but we want to get it to that point where we have a full outer shell. And so there's a couple ways to do this. So before we write out some of these examples, there's a couple ways to figure out the oxidation number. You should know what group it's in. All right, the group will tell you how many it has in the outer shell. We've already talked about this. We said like all the elements in group 1, these all have 1 in their outer shell. All right, all the elements in group 2, these all have 2 in their outer shell. All right, and then remember we skipped this dip. We're like, nah, we're not going to count this. And then these all have 3, 4, 5, 6, 7, and 8, except stupid helium. All right, so to figure out the valence electrons, it's not that tough, but that's not what we're trying to figure out. We're trying to figure out what the number would be to make it so that it has a full outer shell. All right, so this first part's actually not too difficult. All right, because if you think of it like, well, metals. So on this side of the periodic table, metals are going to lose electrons. They're just going to lose electrons. So they have 1, like lithium. I'll draw a lithium atom here really quick. Hang on. All right, here's my lithium atom. Well, if lithium can just lose this 1 electron right there, all right, that next level, remember that the first energy level is filled with just 2 electrons. It's considered full. So if I can just lose that 1 electron, if I can get rid of that, then I will have a full outer shell. All right, and I want that so bad. So lithium, if it can lose 1 electron, it's going to gain a full outer shell. So lithium, then, the way you would write an oxidation number, all it's got to do is lose 1 electron. All you would do is you would just put a plus sign. And remember, the reason why we're writing a plus sign is because it is losing. What's it losing? It's losing an electron. All right, and we got to get it out of our head like, oh, I lost something that's negative. No, it's losing a negative charge. All right, so we're going to write the resulting charge that it has. So remember, protons are positive. Neutrons are neutral, so we don't count those in terms of the charge. So we have 3 positive charges. Well, once that electron goes away, see ya. Now we have 2 negative charges. So the resulting charge, if it loses that electron, would be 3 positives and 2 negatives. So it's going to have a positive charge. So it's losing a negative. So you're going to write down the resulting charge that it will become. All right. So all elements in this group, all right, will have a positive 1 oxidation number. All right. And then you can imagine, obviously, beryllium is going to end up having magnesium. They're going to have a positive 2, or 2 positive, whatever. You can write it either way. It doesn't matter. All right, now the tricky part, so whatever they have in their outer shell on the left side, that's just what they're going to lose. That's the easiest way to do it. Now the tricky part to do it this way, though, is that you have to think, well, oxygen, let's say oxygen's in group 16, it has 6 electrons in its outer shell. So you can do some basic math and say, well, it's got to get to 8. It only has 6. All right, so I know then it must gain 2 electrons because it's in group, once again, oxygen's over here, it's in group 16. Oxygen's right here, it's in group 16. It's got 6 in its outer shell. It's got to gain 2 electrons in order to have a full outer shell because it's got 6 and wants to have 8. All right, so it's going to gain 2 electrons in order to have a full outer shell. So its oxidation number, it's got to gain 2 negative charges. All right, and the reason why, once again, it's negative even though it's gaining is because it's gaining negative charges. It now, if it gains those 2 to have a full outer shell, all right, then it will be stable, but it'll have 8 protons and 10 electrons, so it'll have 2. All right, so and I think honestly there's a better way to do this. All right, so I'll go through that in a second. All right, here's the second way. The noble gases, we know this in group 18, they're chemically stable. They have a full outer shell. All the elements, the goal of bonding is to have a full outer shell, just like the noble gases. All right, so an easy way to do this I think I actually try to combine ways, but just count spaces to the nearest noble gas. All right. I think it gets confusing when you do it this way with metals because you got to go backwards. But I think this helps. So all the elements on the periodic table, they want to be like these guys, the cool guys, all right, the noble gases. All right. So what we want to do here, right, these noble gases. Once again, they all want to be like them. It's like they're like the Mr. D of elements. You know what I mean? Like they just want to be like them. And so what you can do, an easy way to do it, is just put your finger on. Let's say I'm trying to figure out the oxidation number of nitrogen. So I'm going to put my finger on nitrogen, and then I'm just going to count the spaces it takes to the nearest noble gas. So nitrogen is 1, 2, 3 spaces away from neon. Well, that's nitrogen's oxidation number. All right, nitrogen would be negative 3. All right, it would have to be gaining 3 negative charges. All right, it should be probably written the other way, but that always confuses students when I do that, so I'm going to write it this way. All right, and say, oh, well, what about sulfur? What about sulfur? Well, sulfur is, put my finger on 1, 2 spaces away from argon, so I'm going to write it as a 2. All right, now you can use this method for the metals, but it's actually confusing because if you actually counted, like magnesium is 1, 2, 3, 4, 5, 6, 7. That's not going to be. Magnesium's not going to end up going to the right. It's 6 spaces away from argon. All right, it's actually much closer to just go back the other way. If I'm trying to find magnesium, 1, 2. All right, it's 2 spaces away from neon. So if I go left, it's 2 spaces away from neon as opposed to 6 from argon. All right, I actually think that way is kind of confusing. I just think, hey, these are going to lose whatever they have. If it's 1 or 2, they're going to lose them. All right, but then to figure out however many, if I want to figure out antimony, it's put my finger on it, and then it's 1, 2, 3. All right, it's got 3. Its oxidation number then will be negative 3. It's going to lose, or it's going to gain those 3 electrons. All right, so that's a way you can find the oxidation numbers as well. All right, whoa. All right, so either way, it doesn't really matter which method you choose, but finding oxidation numbers is going to be important. So let's go back up here and let's figure out some of these. So if I have fluorine, I know some of you guys are doing it, might as well join in. Fluorine is here, it has 7, it's 1 space away from neon. All right, so I'm going to write that as, so fluorine would be written as negative. You can just put a negative, you don't have to put a negative 1. Let me zoom in on that real quick. All right, fluorine would just be a negative. You can't put a negative 1, I'm not going to ding you for that. And then nitrogen, zoom out, nitrogen, we already did this one, but nitrogen is here. All right, it's right there, 1, 2, 3. All right, don't count the space, just put your finger on it and then move it over. It's 3 spaces away to the nearest noble gas, so it's going to gain 3 electrons, 3 negative charges. Aluminum's a goofy one because aluminum is actually located right here. All right, but if you count it to the nearest to argon, it'd be 1, 2, 3, 4, 5. It's 5 spaces away. All right, that's not that close. So we want to actually go back the opposite way. So we're going to go to magnesium, and then sodium, and then back to neon. All right, neon is actually the nearest noble gas to aluminum, so it's going to gain 3. Magnesium, once again, magnesium is here. It's in group 2. It's going to lose 2 electrons. That's why it's positive. It's losing negative charges. Oxygen's in group 16. It's 2 spaces away from the nearest noble gas. All right, so the point is to write the charge that it will become once it has gained that full outer shell. All right, so it's how many it needs in order to have a full outer shell to become stable. So the number of electrons needed to gain, lost, or shared to become stable. Have that full outer shell. All right, so that's what we want to focus on with oxidation numbers.